I am happy to here and to speak about the current state of DME technology development in Korea. My name is Wonjun Cho, and I'm in charge of the technology development of the DME project from the Korea Gas Corporation R&D division. Today, I'm going to talk about the current status of the Kogas DME technology and the business. First, I'd like to explain the DME information and its application. And secondly, I explained the DME manufacture and the utilization technology. And then I'd like to talk about the DME market, perspective, and the business plan in the Kogas. As a public corporation, Kogas is solely responsible for nation's import and the supply of natural gas in the domestic market. We had import the LNG from the natural gas resources owners nations, Qatar, Brunei, etc. And we co-gas storage LNG in the LNG receiving terminal and distribute to 32 city gas company and 29 power plants. This image shows the pipeline network of Kogas natural gas infrastructure in Korea. We have 3 main LNG receiving terminals in service and 1 is under construction. We are planning to supply to LNG in the Jeju Island. Linking all these terminals, the Kogas is operating over 2,588 kilometers long a pipeline network and an extension of the pipeline which will be 1,286 kilometers long is now on the way. As of January this year, Kogas is actively engaged in the 26 Urbancy projects, including exploration and EMP, as well as liquefaction and the terminal O&M project in 16 countries around the world. Let me introduce the DME. This slide shows the chemical structure and the general properties of DME. As you know, the DME is dimethyl ether with a chemical structure CH3OCH3 has the smallest number of the carbon atoms or of ethers. DME is easily mixed with LPG, and the DME Pure properties is similar to diesel oil. This makes DME a good candidate for alternative fuels. DME can be produced from the many natural resources, such as natural gas, coal, biomass, CBM, and its characteristics are often expressed as a multi-source and multi-purpose clean fuel. DME is the state of the gas phase at room temperature and atmosphere, and is also liquid phase under minus 25 degrees C or 6 bar. The physical property of DME is similar to LPG, so DME is easily mixing with LPG and can use the LPG infrastructure. And DME Pure properties is similar to diesel oil, which have almost the same range of cetane number and can use as an alternative diesel pure. DME is a colorless gas with a slight sweet smell at ambient temperature and air pressure. This slide shows the environmentally friendly property of DME as a fuel. The cetane number of DME is 55 to the 60, which is higher than the diesel. As DME has no carbon-carbon bond in its molecular structure and is an oxygenated fuel, its combustion essentially generated no soot. Because soot is not generated with DME fuel, the recycling ratio of the exhaust gas can be raised and NOx emissions decreased greatly. Cleanness of DME is also superior compared to that of diesel. This slide has shown the emissions from the various fuel vehicles. As you can see, emission data such as NOx, carbon monoxide, and hydrocarbon, and PM. PM means the particulate matters. DME Pure is more clean energy than other fuels. Diesel oil is regarded a major source of air pollution in large cities. DME Pure has very low emission, and then DME is one of the ideal fuels for diesel vehicles replace. And this is the DME properties and the comparison with other fuels. DME can be easily liquefied below the minus 25 degrees C or above 6 bar. Therefore, storage and transportation using LPG infrastructure is possible. Because of almost the similar value of cetane number, DME is a suitable or diesel engine fuel. DME is non-toxic and decomposes easily in air, so it can be used on an aerosol. This slide shows various application areas where the DME can be used, including LPG blending, small size power plant, transportation for diesel-driven vehicles. DME has used the cosmetic, spray propellant, and the intermediate of the agricultural chemicals and the DME LPG blending fuels. In future, DME will be used for LPG replace fuel or blending of gas stove for home use, a small size power plant fuels, and the transportation fuels for diesel-driven vehicles, small medium truck, and the DME city bus. This slide shows how the DME is manufactured. The syngas is first produced from the steam, the CO2, oxygen, and the natural gas, and the syngas is converted to DME either using direct synthesis or indirect synthesis. Direct synthesis is a single-step process developed by the Kogas. This table to compare Kogas direct process and the indirect process. One of the main advantages of the Kogas direct process is that the process is less complex due to its a single-step method. This slide summarizes the status of the Kogas DME technology development. The figure on the left is the picture of the Kogas DME demonstration plant of 10 tons per day capacity in operation since 2008. In addition to the demonstration plant, 50 kilograms per day DME pilot plant was constructed in 2003 and has been used for technology development. All the core technologies in Kogas DME process have been developed and ready for commercialization. And Kogas is pursuing several projects overseas for commercialization. The core technologies in the Kogas DME process are the tri-reforming the catalyst and the DME catalyst shown in this slide. We can guarantee the catalyst the lifetime about 8,000 to 10,000 hours, and we had already proven the performance in the demonstration plant, and we have complete the unique design for tri-reforming and well-heated controlled DME reactor. As mentioned before, the Kogas development was almost finished at 2008. With the DME technology of Kogas, we are going to the business for the commercialization of DME plant in the gas field. Please have a look at this table. We have contract and contracting with 4 countries for the commercialization of the DME plant. In Malaysia, we have started to negotiate the gas price with the Petronas. And Kogas successfully developed the design package for commercializations of the Kogas technology at the 300,000 ton per annual and 1 million ton per annual capacities, and the technology is ready for commercializations. Kogas DME technologies can be summarized as 4 advantages. Firstly, the Kogas process has patent dry reforming technology using 20% of CO2. And secondly, Kogas process efficiency is higher than the others by 10% because the conversion rate of the DME catalyst is high. Thirdly, Kogas EPC process is lower than others through direct DME production technology. Finally, operation cost is lower than others by 5 to 10% due to the above reasons. We think that the Kogas DME technology have the competitiveness over other company. And the space and the weight are the critical factor for efficiency operation of FPSO vessel. The FPSO means that the floating, the production, storage, and the offloading. It is offshore the ocean-based plant. So the module design is necessary for the FPSO design. Every equipment should be located inside the vertical column and diagonal the brace area. Kogas has complete the module design for the DME FPSO plant. Let's move to the topic of the DME useful applications. Due to high set number and low emissions, DME is suitable for the vehicles fuels. Several vehicle technologies are developed or under developing globally. In Japan, the 9 kinds of DME prototype vehicles are developed and demonstrated. In Europe, companies such as Volvo developed and tested DME medium and heavy duty trucks. In Korea, DME Pure supply system was developed, and 1.5 ton DME truck and minibus are being tested. This slide summarizes the DME project in China, from core-based DME production to DME application, such as LPG blending and the DME vehicles. In China, they use the LPG DME blending fuels, which mixing ratios is 30% of DME and 70% of LPG. This slide shows the route and area of the road test of DME vehicles in Japan. Japan had constructed the DME plant by the methanol dehydration process in Niigata since 2008, and the DME product was used for the fuels of road test and small duty trucks by Isuzu and Toyota. This is the 9 kinds of prototype DME vehicles developed in Japan. This slide shows the DME vehicles activity in Europe and the USA, including the extensive field test by Volvo. This slide shows DME minibus development and test in Korea. In Korea, especially Kogas and Kiev has developed the demonstrated minibus driven by the DME fuels. The emission results showed dramatically to reduce the PM. The performance of the DME minibus was similar to diesel fueled vehicles. This slide is a series of tests performed in Korea related to LPG DME auto gas vehicles, including transport of DME from the DME production to filling station, vehicles, the field test, and the mode test. Korea Management Institute have developed the LPG DME auto gas vehicles by filling 5% the DME into the above 90% LPG, and it has tested a 60,000 kilometer test field test. We do not modify the LPG gas vehicles. We use directly LPG and DME Pure for this car. This table shows the draft DME LPG specification for auto gas. The contents of DME may be the 5% of total amount because of its combustion properties in the spark injection engine. And this slide shows the DME SUV vehicles developed and tested in Korea. Various items have been developed and tested, such as engine test, ECU mapping, and pure feeding system in order to improve vehicles' performance and drivabilities. DME Pure is also a good fuel for the power plant as alternative fuels. This slide shows the activities in the GE, Hitachi, and MHI. MHI as a Mitsubishi Heavy Industry to utilize the DME as a fuel for power plant. The efficiency is expected to be similar to gas turbine, while the emissions will be lower than the conventional power plant fuels. This page shows the replacement of diesel engine for electricity. All tests of diesel engine for small size power is already completed, and its performance is similar to diesel fuel. It is easily to retrofit the diesel engine to DME engine. Kogas has already tested for performance of 35 kilowatt DME Cogeneration System by KOILTECH. This slide shows the DME utilization in boiler for industry and agricultural applications. As I mentioned before, DME can be easily blended with LPG up to 20%, and existing LPG infrastructure can be utilized. This slide shows the DME production and the mixing process in the import terminal of the LPG, and then we distribute the DME LPG blending pure by LPG cylinder to the home and the industry and the users. And I will talk about the DME market in the future. DME market for Northeast Asia is China, Japan, and Korea is summarized in this table. Two cases are considered. The case 1 is for the LPG DME blending market, and case 2 is power plant and the transportation market. As you can see, the case 2 is more rapidly increasing rate than the case 1. The China market represents the 80% of the Northeast Asia market. And the main usage in the Japanese market is for the aerosol in chemical. And the DME market for the Southeast Asia is summarized in this table. A primary usage of DME in this market is for the LPG DME blending, and 85% is consumed in Indonesia. And DME market for Europe is summarized in this slide. LPG DME blending is not used and mostly used as an aerosol. As you can see, in Europe, the DME market is very slowly increased. We expect to increase DME usage in diesel replacement if DME market is active in other countries. And DME markets for America and Africa is summarized in this slide. I insist on the rapidly increasing aspect at 2023 because the production of DME and methanol will be increased in Trinidad and Tobago. Mainly, the LPG DME blending is not used and most used as the aerosol. This slide estimates worldwide DME demand from the 2011 to 2012-3, and it showed a steady increase in DME demand. Until 2023, we expect the DME worldwide market is 18 million tons we expect. And this table is the DME specification by characteristics. DME of Korea successfully met DME specification ISO standard. And Japan already established the standard by the GIS, and the USA prepared the DME standard by the ASTM. From now, I'd like to explain the project status of Kogas. I will explain the main DME project. The first is the Malaysia. It is maybe the Malaysia project. So we applied the location to Malaysia. Maybe the Sipitang, the Sojip. Sojip means the Sipitang Oil and Gas Industrial Park. And the capex is 349 million investment dollars over 3 years, and the OPEX is the 150 million dollars per year, including land lease, natural gas, utilities, the maintenance, labor cost, etc. And next is the Nigeria. The project scope in the Nigeria involved the DME production, transportation, import, and wholesale. And transport the DME to neighborhood nations is distribute and sold. Applied locations in the Nigeria is Onne, the industry complex. In Mongolia DME project, DME are produced by coal reforming process. As you know, Mongolia has so many coal resources, but its quality is very low rank grade, so that it may need to convert high rank grade coal, and then from the byproducts we produce DME and electricity. This project may need more the discussion with the Mongolia government, including project financing and national development planning. I will suggest the DME business chain like this slide. First of all, we are developing the gas field in order to supply DME as an alternative diesel pure, and we are correct the company for the project financing in order to construct the DME plant, and we are looking for off-taker which can supply DME to diesel station. And I talk about the Korea project, DME project. This is a common nail, a 2.9 liter DME lightweight truck, and the band technology development. We have already road test and the monitoring plan for DME, substantiation, the optimizations, and durability test. And we also planning to the supply of DME to agriculture heating facility in Jeju Island without natural gas supply to replace petroleum-based fuels. And this slide shows the DME project and the R&D schedule. Kogas will prepare to construct the DME plant in overseas projects step by step. In case of Malaysia, we are faced to negotiate the gas price with Petronas, and we will discuss the DME supply with the off-taker. At 2017, we are to start to supply DME to domestic end user or internationally DME interesting related the countries. And this is a final slide and summarized. To supply the DME in Korea, we participate in the government policy that is in energy diversifications and energy price decrease, which can promote the Korean public welfare. Also, it is an eco-friendly distribution and sales infrastructure improvement, and furthermore, it will bring the job creation opportunities to related industry. It is also to enhance the corporation value when the Kogas start to DME business. As I mentioned above, but the DME growth is expecting to increase. We will develop the global market in the overseas project, and we expect to preoccupied in the DME global market. We are expect to supply the 3 million tons DME in the 2013 this year, and 18 billion tons in the 2023. And now we have the Q&A times. I will explain the technical side, and the Kogas advisor, Mr. Lee, will explain the more detailed DME business as well. Thank you for your attention.
What type of cooperations you see possible with Israeli companies or startups?
So thank you for the question. Okay, first, so maybe and we can find two cooperation way. Number one is so one partner of Israel and Kogas would construct a bigger DME manufacturing plant in Israel, whose natural gas sourced from the Israeli and gas and resources. Okay, and then and second option is that and we can and transfer our technology and manufacturing and technology to our and Israeli and partner so who construct their own plant in Israel. So and we are open for and any options and whatever so we own technology and Israel is looking at the case and aiming at the same direction now. I think that we can find very viable solutions in the future. And and my friend Mr. Iyal and Elich is here to listen to our presentation today, and we are working with Iyal together to find very viable solution for the Israel fuel and alternative and strategy, which is dissolved by the Israel cabinet.
What's the purpose of building this floating production storage something?
Designed for the an Australian case, and they have some gas resources in the sea, and we can take out the gas from sea, and we can construct as FPSO DME and operating plant on the ship. Okay, so as you know very well, okay, so, and Korea is very strong in the shipbuilding industry, and we can construct a DME manufacturing plant on the ship, and produce DME there on ship, and and bring the DME to Israel and Korea. Okay, so that is. But for the case of the Israel, luckily, and Israel is. And explore the very nice and gas resources from the Levant basin already, and gas resource of Israel is very huge, and which is sufficient to produce DME onshore. So we don't have to spend money and and some extra effort to construct FPSO DME plant in the port case of Israel.
So it is my understanding the FPSO plant is designated for smaller fields.
Right, exactly. So if you see as and Grove, so there are so many resources of gas around the Indonesian Ocean, so between and Indonesia and Ireland and Australia. So there are many rich and gas resources there. Then and we are looking at some opportunity to construct a FPSO DME and manufacturing facility. And around there, but still it is not so feasible because FPSO the companies more and capital requirement than onshore manufacturing. Yeah. So usually the whole facility is constructed on the top of the vessel ship, right? So the fabrication and installation of the facilities and same facility on ship would be a little bit so higher than onshore fabrication. That is major reason. So and both and Dr. Beck and myself would join tomorrow's and Israel government the fuel choice summit. So in other words, that is alternative fuels, fuel choice summit. So and and we are expecting much more and creative opportunity to find more and economical and viable humans choice of fuel energy independent from the petroleum base. So and we are expecting big opportunity as well tomorrow. And you can contact our and embassy and and our partner and Mr. Yao and Rich for further question if you have in future. And we are open and ready to communicate with you whatever the questions. Thank you very much.